Bismillahirrahmanirrahim, my dear student of 7th class. Now we move on to the next very important GIT gland, that is the liver. You all know the liver is the largest organ in the GIT below the diaphragm. Now we will briefly discuss the histological aspect as well as the functional aspect of liver. Now, briefing about the liver is that the largest gland and second largest organ of the body next to the skin. ये बच्चों आपको पता ही है कि लार्जेस्ट ग्लैंड है और नेक्स्ट टू स्किन ये बॉडी का सेकंड लार्जेस्ट ऑर्गन है. स्टोर एंड अब्जॉर्ब द न्यूट्रिएंट्स कमिंग फ्रॉम द जीआईटी. जीआईटी के सारे न्यूट्रिएंट जो कि अब्जॉर्ब होती हैं, दे स्टोर एंड अब्जॉर्ब वाया द पोर्टल वेन into the liver. Weight is approximately 1.5 kg in adult, situated in the right hypochondrium below diaphragm. 70 to 80% blood comes from the portal vein. All the material are absorbed from the intestine through portal vein except chylomicron, lipid molecules which are absorbed by lymphatics. The waste and eliminated substance are excreted through bile, the emulsifying agent for lipid. In this slide you will well understand that how much important this organ is. 70-80% जो blood है portal vein का वो drain होता है in the liver. So all the types of material in the GIT absorbed, they pass on to the liver except chylomicron, which are absorbed by the lymphatic. Chylomicron are the end products of the lipid metabolism, so it is absorbed by the lymphatic, not come on to the liver. The waste material are excreted through bile, and this bile is also act as emulsifying agent for the absorption of lipid. Function of liver, it has a wide range of the function as in this slide will tell you. Purification, protein synthesis, production of biochemical necessary for digestion, glycogen storage. This is the glucose storage in the form of glycogen. Decomposition of red blood cell, because when the red blood cell become deformed or old aged RBC, they are decomposed within the liver. Plasma protein synthesis, again very important function, because all the plasma protein present in the blood are synthesized within the liver. That is the endocrine function. The exocrine function is, that is the bile. Hormone production, various types of testosterone, other steroid hormone, some part, they are also takes part in the production of liver. Major role is in the metabolism of liver is about the carbohydrate metabolism, fat metabolism, as well as protein metabolism. They all play a role during all these metabolism. The liver is necessary for survival. There is currently no way to compensate for the absence of liver function in the long term. So it is a necessary organ. Without this, life expectancy is zero. Now this is again a tabulated form of the broad functional aspects of the liver. 500 vital function. Among these, the important function of immunity against infection, very well known, because various plasma protein as well as immunoglobulin that are also stored within and synthesized within the liver. So against immunity, against infection is also mediated by the liver. Regulated blood clotting, all the clotting mechanism are protein. So these clotting factors that is also produced within the liver. Fatty by protein synthesis and cholesterol, important function because of the all the plasma protein and steroid hormone, as well as the cholesterol is the pioneer in the steroid hormone. So the production is within the liver. Clear blood of drugs, chemical, alcohol detoxification is the important function, because all the drugs coming in the body, they are detoxified within the liver almost. Excrete waste via bile. So bile is the end product, that is the exocrine part of the liver. They are concerned for the emulsification of fat and thus thus help in absorption of the fats. Convert excess glucose to starch for storage. When the blood is more glucose, so it is converted into glycogen in the form of storage. So at the time of need, during starvation, this glycogen is again degraded into the glucose for ready use. Excrete bile for fat digestion is again important function. The last one. Now the histology we concerned is of this liver is that is covered by a connective tissue capsule called Gleason capsule, which is next to the peritoneum. Always remember that the peritoneal covering, the liver is in intraperitoneal structure. So next to the peritoneal covering, see a well-defined capsule. This is known as Gleason's capsule. Thicker at the hilum, where portal vein, hepatic artery, and hepatic ducts, lymphatic exit. The hilum is the structure where the structure is going. The hilum is the structure of the liver, where structures are coming in and out. So over here, the stroma, the capsule become thickened. The vessel and ducts are surrounded by the connective tissue capsule all the way to the hepatic lobule, where onward radicular tissue from the framework. ये बात यहाँ याद रखने वाली है कि ये Gleason capsule move up to the portal triad, hepatic artery, portal vein, and bile duct, and divides the liver and parenchyma into lobule. But thus, within the lobule, the sinusoids, the hepatocyte framework, space of dizzy, all structures are covered by the reticular tissue, reticular fibers. So it is very important because these reticular fibers form the stretchable, very well organized system of connective tissue fibers. The reticular tissue support the hepatocyte, duct system, sinusoids, and endothelial lining. So I already told you that this reticular framework gave the support to the hepatocyte, duct system, sinusoid, and endothelial lining. Now this is the diagrammatic presentation of the connective tissue stroma of the liver. Look at the picture in this. This is the H&E stain. Now this is the Gleason capsule, thick fibrous connective tissue beneath the peritoneum. It will give the connective tissue septa within the parenchyma, moving along with the bile duct, hepatic artery, and portal vein into the portal triad, and dividing the liver into multiple hepatic lobes or hepatic lobules. These are the central vein. These are portal triad. These are portal triad. This is central vein of the portal lobule. So this move inside, dividing the parenchyma of the liver into multiple lobules. Now this is the framework of reticular fiber. How delicate, how organized. In between, these are hepatocytes, and these hepatocytes, these are the sinusoids, and this is this over here. We see the central vein as well. So these reticular fiber, they organize the sinusoid, endothelial lining, hepatic lobule framework, and in between present the hepatocytes. So it will give the added supportive connective tissue framework within the hepatic lobule, especially in the liver sinusoids, along with the duct system as well as space of dizzy. Now what are the liver lobes? Broadly, the visible lobe, the gross lobe are the right and left, along with the caudate and quadrant lobe, visible on open eye and under section spectrum. So all have the right and left hepatic duct common and a common hepatic duct. So if we further these right and left lobe by division of the connective tissue septa, the unit structure, that is the hepatic lobule, which are hexagonal. In this diagram you see a hexagonal hepatic lobule, central vein, and at the periphery you see a portal triad, portal vein, hepatic artery, and bile duct. So bile duct, hepatic artery, and portal vein. The portal triad at the corner, the hexagonal structure in the center is the central vein, and these are the multiple sinusoids draining this hepatic vein into the central vein, and this is the system of the unit structure system of the classical liver lobes. broadly larger row visible grossly and then ultimately into hexagonal hepatic lobule. This is the gross feature of the anatomical feature of the visceral surface of the liver. What is the hepatic lobule? A structural and functional unit. ये बच्चों को याद रखने वाली बात है कि it is the hepatic lobule is the functional and structural unit of a liver. Hepatocytes are the basic unit of a lobule under light microscopy. It is hexagonal in shape. अगर हम light microscope देखें तो ये hexagonal है. And basic unit क्या है? Hepatocytes. The lobule size is about 0.7 to 2 millimeter. 0.7 to 2 millimeters. The size of the hepatic lobule. The lobules are in close opposition with little amount of connective tissue. Opposition close होती हैं, मिले हुए होते हैं hepatic lobule hexagonal with little amount of connective tissue element. In the central lobule is a central vein. The corners are demarcated by the connective tissue covering, having portal vein, hepatic artery, and bile duct. Portal vein, hepatic artery, and bile duct. That is the portal triad at the corner of this hexagonal lobule. Lymphatics and branches of vagus nerve also this area in the portal triad. Lymphatics and branches of vagus also present within the portal triad. Now this is diagrammatic presentation of hepatic lobule. Look at the picture. Now this is the central vein, hexagonal in shape. At the corner you see a portal triad, portal vein, bile duct, and hepatic artery. Interlobular artery, interlobular vein, and interlobular bile duct. Now these are the branches which pass into liver sinusoid. These are hepatocytes. They form a continuous sheet, elongated sheet. In between the sheet you see a sinusoid draining the portal vein, interlobular portal vein. Now these are multiple hepatocytes. This is the classical picture of a hepatic lobule. This is the H&E stain of the hepatic lobule. Now see in this diagram, this is low power diagram. If we enlarge this, you see a central vein, and these are the plates of the hepatocytes radiating from the central vein toward the periphery of the hepatic lobule. Now picture is quite obvious. In between the hepatocyte you see spaces, and these spaces are called the hepatic sinusoid, and these spaces are hepatic sinusoid visible in this diagram. And this is the area of the portal triad at the corner of the hepatic lobule, hepatic artery, portal vein, and bile duct. Structural difference you will have to memorize. अगर कोई पूछे कि पोर्टल वेन कैसे आइडेंटिफाई करोगे, हेपेटिक आर्टरी कैसे आइडेंटिफाई करोगे, एंड बाइल डक्ट. इस डायग्राम में आप गौर से देख लें स्ट्रक्चर. पोर्टल वेन इज ए लार्जर having a larger diameter. Lining endothelium is present, but there is no tunica media. It is a collapsed or larger blood vessel having blood in it as well. Hepatic artery is well defined caliber artery having tunica intima and media as well, because media mean that is the smooth muscle layer is also present all around the beneath the endothelial lining. This hepatic artery is smaller lumen, well defined lumen containing RBC as well. Moreover, it has a tunica media muscular layer and tunica adventitia also around it. But portal vein is larger caliber collapsed one. Bile duct feature is a narrow lumen lined by the cuboidal cell. Important, that lined by the cuboidal cell. Cubical cell, the nuclei of cubical cell with the narrow lumen is the picture of a bile duct. So you will have to differentiate. इसको differentiate करना है आपने. Histology क्या difference होगी? Portal vein के endothelial lining है, but there is no tunica media visible. Larger lumen, hepatic artery, narrow lumen with well-defined tunica intima, endothelial lining, well-defined tunica media, muscular layer around it, and then the bile duct is the lining is the cuboidal epithelium. Now these are the clinical lobules. These are the anatomical lobule previously. Now we can discuss the clinical lobule because these have a certain clinical application. अब इसमें गौर से देखें अगर हम 3 क्लासिकल एनाटॉमिकल लॉब्यूल को यूनाइट करें इन द फॉर्म ऑफ दैट एट द कॉर्नर देयर इज ए central vein, and in the center only one portal triad. Look at the picture. One portal triad, 3 central vein of 3 consecutive, 3 neighboring hepatic lobule. They form a triangular structure. This triangular structure is called as portal lobule. Not the hepatic lobule, it is named as portal lobule. 3 portal vein at the corner. Central is the portal triad. Central is the portal, at the corner is the central vein 3, in the center is the portal triad. So in this portal lobule you see the significance is this: only one portal triad is draining that lobule. That is, it means it will supply all the 3 classical hepatic lobule on all the sides of the triangle. So whenever the pathology will be spreading from the center up to the periphery to the central lobule, to the central vein. So this is the, when pathology occur, it will affect the neighboring 3 lobule, classical hepatic lobule, because it is only one portal triad in the center in this portal lobule. Now further we see the last one is the portal acinus. This is the smallest subdivision of a hepatic lobe, smallest subdivision. ये याद रखें, portal acinus is the smallest subdivision, and it is very important clinically nowadays because of the hepatic cirrhosis. Look at the picture, it is a diamond shape. It is a diamond shape. ये बात ध्यान रखें. 2 ends are central vein of the corresponding neighboring 2 hepatic lobule. One hepatic lobule, this one, second hepatic lobule, this one. At the corner of the diamond, these are the central vein of the neighboring hepatic lobule, and at the opposing 2 corner you see a portal triad 1 and 2. This is the opposing corner of a diamond. So these diamond had 2 portal triad. So it is a diamond shape. Corners are central vein, and the opposing corner that is are having portal triad. 2 portal triad, 2 central vein of the neighboring classical hepatic lobule. What is the clinical significance? This will divide the portal acinus into multiple zones. Look at the picture in this. The zone 1, zone 2, and zone 3. What is the significance? Because zone 1 has a rich vascularity. Zone 2 is relatively less vascularity. Zone 3 is least vascular, because the blood vessel, that is the hepatic artery, portal vein, that drain from the periphery to the center. So this area, green area, is much more vascular, much more nutrient, more oxygenated, and less toward the central vein, less oxygenated, less nutrient, less oxygenated, less nutrient. That is why the cirrhosis of liver first start from the central area of the classical hepatic lobule. Central area of the classical hepatic lobule. That is mean zone 3 will affect first in the injury of the liver. Injury of the liver, zone 3 will affect first, but the repair process will take place initially in the zone 1. Zone 1 repair process start because it is more vascular, more nutritive, but the insult start from the zone 3. Insult start from the zone 3. ये बात आपको समझाने मकसूद है. पोर्टल एसिनस की क्लिनिकल सिग्निफिकेंस क्या है कि उसकी वास्कुलरिटी डिफर करती है फ्रॉम द पेरिफेरी टू द सेंट्रल. जब वास्कुलरिटी डिफर करेगी तो उसकी हीलिंग, उसकी रीजनरेशन, उसकी इंसल्ट डिफर करेंगे अकॉर्डिंग टू द सप्लाई ऑफ द blood vessel, nutrients and oxygenation. So this is the clear clinical application and the classical clinical view. You should have memorized that because it is clinical application. You will be, ये आपको clinical side पे जब आप जाएंगे तो आपको बड़ी काम आएंगी ये चीज़ें. Zone 1, Zone 2 and Zone 3. Now what is the histology of hepatocytes? This is the structural key unit. Unit structure of hepatic lobule. 20 to 30 मिलीमाइक्रोन इसका डायमीटर है, ईओसिनोफिलिक इन स्टेनिंग है क्योंकि माइटोकॉन्ड्रिया न्यूमरस है, मल्टीपल माइटोकॉन्ड्रिया बिकॉज रिचली supplied by the mitochondria because of the very energetic cell, very metabolic cells, that is why mitochondria are present. Rough endoplasmic reticulum and free ribosomes are also present. Lipopprotein granules are also observed with increasing age. Unstained area of cytoplasm, these are meant for the glycogen. The glycogen is the storage house of the glucose, also present, but it appears to be a unstained area. The average lifespan of hepatocyte is 5 months. एक hepatocyte जो है वो 5 माह का जिंदा रहता है, फिर दोबारा regenerate होता है. They also are able to regenerate. Nuclei round with dispersed chromatin and prominent nucleoli. Binucleate cells are also common. More than one nucleus are also visible. Dispersed chromatin but prominent nuclei for activity of the hepatocyte. This is the diagrammatic presentation, histological picture, electron microscopic picture of a hepatocyte. Look at the picture. There are 4 surfaces of a hepatocyte, one toward the and 2 surfaces are toward the hepatic sinusoid, this surface as well as this surface, and other 2 surfaces are facing close approximated with the tight junction having a bile canaliculi in between the 2 cells. These are the bile canaliculi. Opposing surface, they will enclose a bile canaliculi, whereas the 2 surfaces they will line this hepatic sinusoid. Obviously, you see in this diagram, these are the hepatic sinusoid. These are the endothelial lining of hepatic sinusoid. Endothelial lining are fenestrated, a gap in between the 2 cells. Endothelial lining is the hepatic sinusoid. The 2 opposing surface, so it is clear that the 2 surfaces are almost facing the hepatic sinusoid, whereas the 2 opposing surface that will face the bile canaliculi as well. Now, in the center you see a nucleus with the well-defined nucleolus, the rough endoplasmic reticulum, the Golgi apparatus also visible, multiple mitochondria, other organelles, lysosome as well, and then the multiple Golgi apparatus are visible. Now, these are stunted microvilli toward the space of sinusoids, and these sinusoids you visible in the endothelial lining. So, Golgi apparatus, space of disease. Space of disease, what is that? Space of disease is the cell boundary with the space between the endothelial lining. This is the endothelial lining, and this is the space of disease, and this is the cell, which is the hepatocyte. So, space of disease between the cell and endothelial lining of the sinusoid. This space is called the space of disease. Now, further in the coming slide, we will discuss space of disease in detail. Over here, this will tell you the detailed picture of a hepatocyte. Now, the arrangement of the hepatosinusoid. Now, this picture you see, this is a central vein in the classical hepatic lobule, and these are the double layer of a hepatic cell, hepatocytes. Now, this hepatocyte line a wide canaliculus, this is called as sinusoid. Now, blood moves from the portal vein pour the blood within the sinusoid. After purification, after absorption of the nutrient, ultimately the portal vein drain the blood into the central vein, from where into the hepatic vein, ultimately inferior vena cava. So, portal vein containing all the necessary nutrients that is absorbed and purified within the liver sinusoid, hepatic sinusoid into the central vein. Now, these are the hepatocyte, and between the hepatocyte you see a bile canaliculi. Now, this bile canaliculi ultimately join to form a bile duct tube. Now, this is the hepatic artery. This is the area of portal triad. Hepatic artery also pour blood Hepatic artery also give blood, which is oxygenated blood in the hepatic sinusoid. Now consider it that this hepatic sinusoid contain mixed blood, both oxygenated and deoxygenated. So this area is more vascular, more oxygenated, more nutrient, proximal area. जैसे जैसे आप सेंट्रल वेन की तरफ जाएंगे, ये इसकी nutrient value and oxygenation will become poor. So hepatic artery also pour blood in the sinusoid. Portal vein also pour blood in the sinusoid. The hepatic side line the sinusoid. In between the hepatocyte, you see a bile canaliculi and ultimately drain into the bile duct tube. This scheme you will have to memorize. And in between the space of Dizzy, this is the hepatocyte, this is space of Dizzy. This is the endothelial lining. So this is the space of Dizzy in between the endothelial lining and the hepatocyte. In this space of Dizzy, you see a satellite cell, Kupffer cell as well, and also the I2 cell we will discuss in the coming lecture. Now this is again a diagrammatic presentation in 3 dimensions. This is the portal vein, bile duct tube, this is the hepatic artery. Now this is the portal sinusoids, hepatic sinusoid, and this is the central vein. Look at the picture. So all portal vein through blood in the sinusoid, artery through blood in the sinusoid. The bile duct tube will drain ultimately into the bile duct. Now this is again a diagrammatic presentation of the sinusoid lumen, Kupffer cell, and these are the discontinuous endothelial lining having a pore complex. These are the dendritic cell within the space of Dizzy. These are satellite cell, also called the I2 cell. They are also present within the space of Dizzy. Look at the picture. Where is the space of Dizzy? These are the hepatocytes, and these are the endothelial lining of the sinusoid. In between the endothelial lining and hepatocyte is a space of Dizzy. This is important, you will have to memorize. Space of Dizzy between hepatocyte and endothelial lining, containing the satellite cell, dendritic cell, and the Kupffer cell. So this is the picture representation of the space of Dizzy. What is the sinusoidal histology? Lined by fenestrated endothelium with interrupted basal membrane. Clear? Sinusoid की histology क्या हुई? Fenestrated endothelium with interrupted basal membrane. The hepatocytes lines the sinusoid, but the space in between is called the space of Dizzy. Between the endothelial lining and the hepatocyte, you have seen in the previous slide. Space of Dizzy contain reticular fiber, specialized repair cell satellites are I2 cell. Sinusoid also contain the macrophages called Kupffer cell. In the sinusoid, oxygenated blood is mixed with the venous blood rich in nutrient from portal vein. To understand this, lined by reticular cell, I2 cells and Kupffer cells are the contents of the space of Dizzy. Mixed blood from the hepatic artery and the portal vein is present within the sinusoid. Now look at the picture again. So this is the endothelial channel lined by endothelial cell having discontinuous basal membrane. Now this is the I2 cell between the space of Dizzy, and these are the Kupffer cell present within the lining to purify the blood. This is the perisinusoidal space, also called space of Dizzy. This is the hepatocyte, and these are reticular fibers present within the space of Dizzy. So this is the contents of the space of Dizzy: I2 cell, Kupffer cell, and the lining epithelium. What are the satellite cells? Hepatic cell are satellite cells, also known as perisinusoidal cell. Perisinusoidal cell. These are present in the space of Dizzy. These are parasites found in the perisinusoidal space of liver, also known as space of Dizzy. A small area between sinusoid and hepatocyte. The satellite cell is the major cell involved in the liver fibrosis, which is the formation of scar tissue in response to liver damage. Always remember, when there is a liver injury or liver insult, सबसे पहले जो सेल एक्टिवेट होगा वो सैटेलाइट सेल होगा. Satellite cell will produce the changes within the liver in the form of fibrous tissue within the space of Dizzy, shut down the endothelial perforation, that basal membrane become closed, and all the activity will lie within it, and then the fibrosis will start. So satellite cell or I2 cell that first respond to the liver insult. ये पहला सेल होता है जो कि लिवर की इंजरी को मार्क करता है, सैटेलाइट सेल. Now Concentrate on this diagram, that is the hepatocyte. This is normal phenomena. Look at the picture. So these quotient isotope cells are normal resting cell. Cooper cells are there. These are endothelial lining, discontinuous. Look at the picture. These are the perforation. This is the endothelial sinusoidal space. This is space of disease. Quotient cell, testlet cell is non-active, still present in the. These are hepatocyte. Now, these are the bile ductule in between the two cells. These are hepatocyte. These are bile ductule. This is the I2 cell. This is the endothelial lining of the sinusoidal. This is the sinusoidal capillary or sinusoids of the liver hepatic lobule, and this is the Kupffer cell. Look at the picture over there. Now, what happens when there is an injury? Injury will happen that these cells become active. Satellite cell, I2 cell become active. Multiple fibroblasts produced, and these convert into fibroblasts, and collagen fibers start growing within the space of disease, ballooning the space of disease, ultimately lead into the closure of the basal membrane, and this spaces between the endothelial cell become much more closed. Kupffer cell become activate. Kupffer cell become activate and deposition of scar matrix, activated cell. इस सूरत में जो स्कार बनेगा वो बनना शुरू हो जाएगा. सो इनिशियल इंजरी जो आपको नजर आएगी वो एक्टिवेशन ऑफ satellites or I2 cell, and then there will be activation of the macrophages for cellular debris. Loss of hepatocytes, macrovilli again a feature, because macrovilli become lost during the hepatic injury. So all this is liver injury, loss of hepatic macrovilli. This is the presence of the activation of I2 cell, that is the satellite cell, presence of these are multiple collagen fiber, and then the ballooning of the space of disease and loss of the perforation of the basal membrane of the endothelial lining, activation of the Kupffer cell. These are the features for liver injury. Now this is the high power sinusoidal light microscopy. Look at the picture. This is the central vein. These are the liver sinusoid. No picture. This is Kupffer cell. So hepatic cell, these are binucleated hepatic cell. Hepatocyte, multiple hepatocytes are visible, but Kupffer cells are also present within a space of disease as well as in liver sinusoid. This is the central vein. Now what about the liver circulation? So in this diagram you see a liver circulation. In the portal triad you see three structures, that is the hepatic artery, interlobular portal vein, and then the bile duct. So interlobular artery carry the oxygenated blood, pour their blood within the liver sinusoid. Portal vein throw their blood, which is deoxygenated but full of nutrients, within this liver sinusoid, and ultimately drain into the central vein. From the central vein, interlobular from the hepatic vein, ultimately drain into the inferior vena cava. So this is the circulation. From the bile is produced within the hepatocyte, drain into the interlobular ductule, and then in the duct of the this bile duct, the ultimately bile duct drain into the hepatic duct, and hepatic duct will ultimately goes to the duct, common bile duct, by the this gallbladder duct, ultimately drain into the second part of the duodenum. Biliary system, bile canaliculi, bile ductule, bile duct, hepatic ducts, common hepatic duct plus cystic duct, ultimately in the common duct toward the second part of the duodenum. This is the bile system, starting from the bile canaliculi, then bile duct, bile ducts, hepatic ducts, common hepatic ducts, cystic duct, and common bile duct. Now this is the biliary passage lining epithelium, that is the simple cuboidal epithelium from the bile duct, and then the sinusoid, it is the bile canaliculi, no lining. It is the beveled this plasma membrane of the hepatocytes. Epithelial lining will be visible in the bile ductule, from bile ductule up to the bile duct. So this is the histological picture. Now these biliary system will be visible over here. This is the bile duct. So bile ductule present within these are hepatocytes. So this is the bile canaliculi, herring canal, cholangiocyte, herring canal, and bile duct, portal spacer, right and left hepatic duct, direct bile flow opposite to the blood. So this is the presentation of a biliary system histology, the lining. Thank you very much. You all. Next, inshallah, we'll move on to the gallbladder.